Good morning and welcome to today's webinar. Today's topic is Chapter 8 of the Design and 3D Modeling course guide, and it is in regards to the superelevation on roadway designs, how to apply it, where it's found, how to edit it, so on and so forth. We dedicated a specific chapter in the course guide for superelevation, and typically comes after the your basic corridor has been established, and now it's time to apply the superelevation controls for your corridor. I just moved forward a slide. For anyone new to superelevation, it's duly noted that most of the design standards or the design for the projects are found in the Design Standard Index 510 and 511, and also in the Plans Preparation Manual in Volume 1, Chapter 2, and specifically the roadways are kind of divided up into two main categories, and then which would be a rural or a high-speed urban type facility, which would use a possible superelevation maximum rate of 10 or 0.10. And then also for the urban streets, urban highways and streets, curb and gutter types, and uses a maximum value of 0.05. And there's a lot of differences between the two main category types as far as how they rotate, transition lengths, so on and so forth. So if you're not familiar with those two references, that's where most of our design parameters come from when we go into our automated applications, in this case GeoPack or OpenRoads SS3. And I can talk a little bit about legacy superelevation tools, and primarily I'm going to talk about the new OpenRoads SS3 superelevation tools. I'm not going to get into what superelevation is or why it's needed by now. If you're designing highways, most of that is already information that you already know about, so I don't want to spend a lot of time on that. In this session, we're going to cover what's covered in the chapter or in the course guide as far as the steps involved in getting superelevation on your corridor, and essentially try to cover these 10 topics here. And first of all, where are the superelevation shapes going to be created for your project? Which design file? We'll talk about that. And then the methods for creating the sections and creating superelevation lanes. You'll notice that the shapes are back. That says 2-quarter modeling. We didn't use shapes. We pretty much used the superelevation wizard and went from there. Well, the shapes are back so that you can do graphical edits as well as the diagram edits. We'll talk about where the superelevation is calculated from as far as the tables that we have in the workspace and the parameters that are set in there. I won't get too much into that, but I'll at least point to where that's located. And then just that, I'll talk about editing the superelevation shapes, whether you do it graphically or through the Project Explorer. And then we'll talk about the specific superelevation controls within a template that you need to be aware of, how they all kind of work together. And then we'll assign a superelevation design to a corridor and see how it affects the corridor slopes in the cross-section viewer. We can then go to the superelevation reports and any diagram editing, as well as creating input files. And then last but not least, the whole enchilada of this topic is what are we actually creating? And the fact is we're creating point controls to manage or to override slopes on our template. And I'll explain how all that sort of ties in together. Okay? So let's go ahead and get into a MicroStation session. And as you can see here, this is the corridor, the basic corridor design that was created Chapter 6 and 7 as of last week. Now we're getting ready to apply, based on the PPM standards, a super elevation to rotate our roadway to accommodate this curve. And we just have one curve on this project, so when you have reverse curves, it gets a little more complex, or rather opposite curves with tangents in between or no tangents in between. It can get a little more complex, but we can just talk about the basics in this session. And the first thing you need for creating super elevation is a model to display the shapes in. Now, what we've decided, or what the workflow that we've sort of come up with in ECSO here, is that we already have a shapes model that was used in the legacy criteria for creating shapes. And what I want to do is, or what we decided to do is, we're going to go ahead and use that same model. So I'm going to go ahead and open up the cross-section file. And if you don't know how to create a cross-section sheet by now, you can use the Create Edit tool or the Create File tool, and it loads up or it will create a cross-section design file. In that cross-section design file are several different models, and like I said, if you've been doing FDOT Roadway Design for a while, you know what each of these are. But the last one here is where we typically would put in the shapes for cross-sections and criteria. This is now going to be the shapes, super elevation shapes. So I'm going to just open up that model. And then what we've got to do is reference in the design file. So you see that this is referenced. And I just want to make sure this is not rotated. So I'm just going to unrotate this view so it looks like our other model. And then we're going to go ahead and start laying out, and make sure I have all the levels turned on in here. And it may have been just the construction classes weren't turned on. Okay, so. And the reason you need to do this is because the super elevation shapes are going to be based off of the center line. All right, and the center line is going to be this center line here. Now, we've got to look at our facility type before we start laying out shapes, and also kind of know a little bit about it. And for this project, I'm going to, the course guide has us lay out just some shapes as though we were going to be rotating them about an independent profile grade line on each side. So I'm going to go ahead and do it that way, but then I'll also talk about a method for, in this case, we would need to actually be rotating about an inside edge. So I'm going to try to address that when I get through with this particular design. Maybe I'll even have a chance to redesign it. So I'm going to go a little slower on this first initial pass. So one of the first things you need to do is to remember that most of the graphics that gets created gets put on whatever your active level is. So what we're going to do is set the miscellaneous 0 to be the active level. I'm going to do that just by using my Alt key and clicking on this element, and that will actually set, this is my active level. Now, all of the super elevation stuff that I create will get put on this level. It's just the way the software is set to work. And now, a couple of different ways that you can create super elevation. You can do it from a toolbox under the tools, and then there's corridor super elevation. And there's a whole tool palette here that you can open up separately if you'd like, and then you've got them all here. Or they're also all docked here in the task, so I'm going to go ahead and use them that way. And the first step is to create the super elevation sections. And that's just a matter of just giving it a name. I'll just call this webinar for the name. And then it wants to know the reference element to start building the sections. So this is going to be essentially your holding line or your control line. In this case, I'm going to use the center line initially, but if you were going to be doing an inside rotation, you might use a PGL or some type of control line on the inside of that curve there. And you may have to do it if you had an S-type situation. You may have to have control lines on both sides. But I'm just going to go ahead and select the center line for now, and then you can give it limits. So if you did have reverse curves and you had to use inside lines, you could just give it limits between those curves. But in this case, I'm just going to use Alt. Escape out of that. Hit the wrong button. I'm going to do, and I've also got this AccuDraw on. So the start station, I want to go ahead and lock it to the beginning. So I can either hit this lock to start, lock to end, and then that will basically create the section that way. Then the minimum tangent length, and this has fill turned on. In this view, actually it's probably shaded is what it is. It just needs to be a wireframe. Okay, so now I've got this section. The next step is to lay out the lanes. Essentially, you could see how I could have multiple sections. In this case, I just set up one section for this entire project. And now you're going to define the lanes. And whenever you're laying out super, sometimes it will proceed to the very next sort of step. In this case, I reset out of it, but I can always go back and do the create super lanes this way. And then what it wants to know is where the super elevation section is, so you identify it. And then if you reset, it's going to ask for the name. And so I'm going to start with the right side, R-I-G-H-T, right one. And then it's going to be a primary, not auxiliary. It's going to be right of the center line, so I can use my up arrow or just change it. And then the inside offset, because I have left turn lanes, or because I might want to rotate about the center pivot point rather than rotate about the PGL lines 11 feet off of the center line, I'm going to go ahead and set a lane that goes from 0 to 11 feet. So the first inside edge offset will be 0, and then the lane width is going to be 11, and then the slope that I want it to use is -2 for the right side. And it should have created a shape out here, which you now see in the plan view. And of course, this is all a reference file back beneath there, which is my design. So really all I'm drawing is this boundary, and now I've drawn this shape. And then it also wants to go, I can keep adding lanes here, and this will be right 2. And just put a right 2 there. It'll also be primary, and it'll be on the right side. In this case, it'll be 11 feet from the center, and it'll be 28 feet wide. And the slope is also going to be 2%. And so now I've filled out that lane, and then I can go ahead and add them to the left. So I'll just continue here. Left 1, primary, it'll be left. It'll start at 0, 11 feet, normal, -2, and now it's going the opposite direction, so it changes color. And I select it again, and this will be left 2, primary, left, and this will start 11 feet from the center line and have a width of 28 feet and a cross slope of -2. Now, if you had right turn lanes, this project doesn't, but if you had right turn lanes in here that you needed to add at 3% or an extra lane for bikes, then you could go ahead and hit the extra lane at -3, and then it would rotate those lanes as well. But I'm just going to focus on these particular lanes for now. So once I'm done with that, then the next step is to actually calculate this super elevation. Now that is the next button, and where that comes from is a table. So the first thing, once you hit the calculate, it's going to ask you for the section. When you reset, it's going to ask for you. I hit the wrong button. I hit the assign. I meant to hit calculate. So this is the dialog that I was expecting to see here. So it's asking me to select the section and reset, and then it's automatically going to go through and try to fill out this table. And this is where it actually determines the maximum rate to use for each curve radius. It also determines what the transition length is going to be based on a table. And so let's go ahead and take a look at that table. And that is located wherever your workspace has been loaded. These are the same tables that were used in the legacy criteria method, which is under this eTables folder of the GeoPack folder. So if you look in here, there's different tables for rural and urban. And if I open up this this with an editor, you see all of the various this up here. You'll see all of the various factors that are used, and these were developed specifically for Florida urban. There's also a Florida rural, and it also has the CSV file for the urban based on this curve table. So this is where it's figuring out what the maximum rates are going to be for each of those radiuses. This table comes directly from the FDOT, this particular diagram right here. It also is defined over here in the plans preparation manual right here. So those values were picked out of there and plugged into the actual file. I want to close it. I just want to drop that down. And then there's also the this RG table value, which is what determines the lengths. And so this is the value for transition length of 150 feet per foot, which is defined in the standards. If you do an inverse of 150 over 1, you're going to get 0.0067, so this is expressed as a percentage. And so that's how the background setup is done. Just be aware that if you're using these tools and you're using our urban SEP files, that they're all set up according to FDOT plan preparation manual and design standards. So I'm going to go ahead and accept that. And now there's only really one value to use with an E-table of urban E-table, which is the 5% max. So there's really not a whole lot to set there. And then you just give it the number of lanes. So 2 and 4 lanes would be what I'm using here. I could also use it as 6 lane if I basically want to rotate for a future section. And then you set the design speed. In this case, our design speed is, let's just use 40 for now. And then a linear transition, and the number of lanes again would be 6 lanes. And it's a divided facility. And then you can open up the editor, and it calculates the super for you, and it opens up this dialog. And this dialog is resizable. So what it gives you is a diagram of what's rotating. So these are the outside edge of pavement lanes. This is similar to the quarter modeling super elevation diagram that you got in SS2. And now this has been added. This is a list of each of the controls. So everything that's right 1 is the right 1 control line. Right 2 is the right 2 control line. There's more entries for the left lane because it's the one that's actually having to rotate up, whereas the left lane is going to stay right there at 2% for that particular design speed. Okay, and then you can close this, and if you need to make modifications now, like let's say, for example, you wanted to change maybe the limits of these sections. So you can click on here, and then if you want to pick these station values, you can graphically change it if you click on this boundary, and then there's a little handle right here. So there's 2 different types of edits. There's the whole section edit, and then there's individual lane edits. Okay. In this regard, these little information shields here are for my design standards on my center line. So that doesn't have anything to do with the super right now. So, but what I was going to show you is how if you wanted to change the limits of the whole section, you could just set it to a value of 700 here, and that would move the whole section and all the lanes with it. Or if you wanted to change something about a lane, you can click a lane, and let's say you had the wrong slope on it. Maybe it's supposed to be -3. You can set -3 right here, and it changes the whole section now. And notice the color is a little bit different. Then you can use the edit undo or Control Z, Control R in the superelevation edits. The other thing that you can do is use Project Explorer once you have your superelevation laid out. So now you can see that my superelevation is crowned here. I can see it visually because of the colors. You see there's my center line, so everything's 2% one way and 2% the other. And now as I look up through my corridor, you're going to see that this color is changing to where it's actually starting to be white, which is 0, and then once it gets up there, it will be the same color as the inside lane because it's rotated up. And then once it gets out of the curve, it starts to rotate back down, which is what the white symbolizes, and then you're back to a normal crown situation. Okay. Now I was talking about edits. If you notice, if you pick on a lane, I think I showed you that, it shows you where the transitions begin and end for the different values. So here it's at 2% and it's going to +2%. If you needed to change the value of this for some reason, maybe you had an intersection here or you wanted to narrow it or lengthen it, you can just click on this value and maybe change it to 70350. And now that transition is changed, and basically you can do a graphical edit that way. You could also pick the inside lane here, click on the right handle. And if you can't, you can always use, I just didn't get the handle right. I probably could have got it from one end or the other. But you can also edit this another way, and that is with the Project Explorer. So if I use the F11 key or go to File, Project Explorer, either way, we put a function key just to make it easier. Then if you go into the design file, so if you noticed in all these sessions I've been always going to the Project Explorer and going to the Civil Model tab, because that is where everything that I create is placed in a dictionary type, or a encyclopedia, whatever you want to call it. And so here's the section, webinar 1. If I wanted to rename it, I could rename it right here. I could go to the properties, which brings up the element information dialog. And if I wanted to change something about it, even the name, for example, if I just wanted to call this Web Today instead, I can name it right in Project Explorer. The other thing you can do in here is you see there's superelevation objects. It has the 4 different lanes that I had placed out there, and each one of them has properties that is according to the way that I defined it in the little dialog setup. So if I messed up, or maybe it was supposed to be, instead of 11 it was supposed to be 12, I could just change it right here and just change it to 12 that way. And it would actually change it graphically and also change it in this table as well. So that's just so you know that there's 2 different ways to edit your lanes. Okay. Once you have your superelevation set up, then you need to basically it's calculated. It's all set up in this superelevation shapes file. Then you're going to go back to the design file, and you're going to assign it to a corridor. So far it's only been laid out based on the center line, and so it has no connection to what the corridor has going on with it. So far the corridor is just a 4-lane urban divided section that has no superelevation. So we can verify that simply by going to the corridor. And this is a quick way to get a cross-section view up. I just click on the corridor and go to the second icon, there's the cross-section viewer, and it will ask me for a view. And I'll just open up view 4, click over here, and now I'm looking at this corridor. And then I can go to a specific station. I happen to know that station 712 is right in the middle of my curve, so it's easy enough just to go there. And you'll see that this corridor has just a normal crown situation here. as you go through that. It looked like it was in the middle of the turn lane at 712. I'm going to set this to center on my current offsets. I'm going to Control F to file save settings so that this is always saved this way. Then you can also see that I'm in this corridor right here on the curve. I'm also in the corridor here on the curve, and if I move back and forth, it's just a normal unsuperelevated roadway. So in order to apply the superelevation to it, what we're going to do is first look at the template. This is important for applying superelevation to your templates. There are some controls in here that you need to be aware of. So the template that we've been dealing with for this whole course guide is this template here. We built it in the template design, and now we need to prepare it for superelevation. Now you need to know a little bit about how you're planning on superelevating your roadway before you can set up the controls in your template. In this case, I know what I want to do is I want to rotate my roadways about a center pivot point. So prior to assigning the superelevation to this corridor, I need to make sure that I have a pivot point in here, and then I need to set my edge of pavement lines here, my normal, what we call profile grade lines, to be sloped off of the pivot line. That way, all of these will essentially rotate through this point in a superelevated condition. Now, if you have a situation where you've got to rotate about an inside or an out inside a curve, which would be a higher speed urban type facility, then what I've done is gone ahead and defined templates a little differently. So in this case, what I've got is a template that has to rotate about this right edge. So what I've done is I've constrained it a little differently. First of all, here is my center line, and now the point that I want to have the control is out here on the right, and then everything else gets controlled inward, so that everything is going to rotate about this point. But you have to make sure that you set your template up that way such that this is really the free point rather than either these 2 points or this point. Now in our situation, I've got this set up so that these 2 roadways rotate about the pivot. The whole moral of the story here is that you've got to set your template constraints up so that it pivots correctly with the type of superelevation that you're trying to apply. Whether you need to rotate about the outside, the inside of a curve, or if you're going to rotate about a center point, or if you're going to rotate about the 2 PGLs, you have to make sure you've got your constraints set up right. The other thing that you need to do is a couple of things, but you need to define which points are going to be superelevated or have superelevation controls on them. So in this case, I've got a pivot point which is going to need a superelevation flag, and then I'll have these edge of pavement points which will have superelevation flags. So it's an extra box that you check on your points. Okay? Let's look at a different point. Like let's look at this this point right here. Notice that I don't have a superelevation flag here. However, it should be superelevated according to the slope of the roadway because it's supposed to follow the pavement slope. Well, we can handle that a little differently. So what we do is we normally use what's called a vector offset. And then we define that between 2 points on the pavement. And if those 2 points have superelevation controls on them, then the slope of this follows the slope between these 2 points. And that way we don't have to put superelevation controls on all our points. We only have to put them on our controlling roadway edges. And then everything else uses vector offsets for left turn lanes, for right turn lanes, and not necessarily right turn lanes. A lot of times those are auxiliary lanes that need to be rotated up if they're in a curve, so they're handled a little differently. But let's talk about the other type of control, which is a rollover control. Rollover in SS3 or even in SS2 is usually when you have shoulders. So in this case, this will be a template like this, where I've got a crowned roadway with shoulders on it, and once I rotate one side up, I'm going to have an adverse break greater than 7%. So how do I handle rollover in a shoulder situation? Well, you also got to know a little bit about how these templates are built. In other words, how the constraints are built. So you've got, here's the normal shoulder, or the edge of pavement beginning of shoulder, and then you've got 1, 2, 3, 4 points out here. Well, these points are for rollovers, and you may or may not need them all. It all depends on how your shoulder, physical shoulder is. Do you have 5 foot paved, 5 foot unpaved? Do you have 2 foot paved and 8 foot unpaved? Do you have, whatever combination? The middle point that needs to break may be either in the paved or it may be in the unpaved. At least in the past, I'm not sure if we're doing any breaks on the unpaved anymore. So this point could probably just be deleted, and then it's probably not ever going to break on the unpaved shoulder, if I remember correctly, according to the standards. Regardless, this is usually what's called a vector offset, just like we have vector offsets in the curb points. This point is always going to follow whatever this vector does. So the control is really on this point. And we don't have to apply superelevation to this if we just put a rollover condition on it. And you do that by looking at the point properties. In this case, you see that it has a normal 6% slope. And in order to apply a rollover, what we do is we put this box right here. And then you have to go and do the setup in this rollover dialog. The way this dialog works is it says that the parent point is in the middle, and it's a little deceiving the first time you look at it. And so what you're really trying to do is, this is the parent point that this came from. So that's this middle one. And then it wants to know in reference to, what's the next point out? So this would be the reference point. So all you've got to do is go into this one and kind of skip over this one, because this is a vector offset. Know that this is the parent, and then just pick this point over here. And of course, this is recorded, so I don't expect you all to memorize this. And then all you have to do is set, in this dialog, the maximum rate of 7% on the high side and 0% on the low side. And then choose apply and close. And now, no matter what this does, that outside point will rotate itself up. So see how this, when I rotate this edge of pavement, watch how the shoulder starts to bend with it, so that it never breaks more than 7% on the high side and 0 on the low side. So again, it's just a matter of clicking on the point that you need the rollover controlled on, checking this box rollover, going to this, and then clicking on the reference point, which is you've got to skip the parent point and pick the next point over. In that case, it'd be the pavement crown, and then choose OK. Now, when you have multiple lanes, you may, let's say there's 5 or 6 lanes and everything kind of comes off an auxiliary lane. Well, the reference point might be an inside edge of pavement or a travel lane. You do the same thing over here. Now, this point right here, you could also put a rollover brake on it as well. And you could just come over here. Now, remember to skip the parent point and then pick the reference point, which would be this point, and say that this can never break more than 4%. Or if it's on the high side, and on the low side it'd be 0. And then that will help control this break in the shoulder here. Now, it may not apply to every situation, especially when you get into the higher superelevation rates of 09 and 10, in which case you may have to go in and create a separate control line for these. But we've done that in the past, and I've got webinars on doing that. The old tools. We'll just have to create some webinars for the new tools. But this will handle most of the speeds below, well, the larger radiuses and lower speeds. It may not handle all the situations. That's just a little bit about the template controls. So you've got to remember to make sure your template is constrained the way you want to pivot it. And you also need to make sure that you have your superelevation flags checked. And then you'll also need to set up any rollover values, or rollover situations on shoulders, and you don't necessarily have to worry about them on curved. But what you will want to do is make sure that your curves are using vector offsets so that the slopes of the inside curves follow the values of the pavement. So, just a little bit about superelevation template controls. So once you have all that set up, I'm going to close and save. Then what you're going to do is use the next option, or the next button, the fourth one in, which is assign superelevation to corridor. And first thing it wants to know, well, before you can do that, you have to reference in your superelevation design. So I'll just go to my reference files and attach the roadway, the RDXS, and make sure that I'm attaching the superelevation shapes. And if you'd like, you can even rename this. And then make sure no nesting, no raster, choose OK. And you see it displayed here. You can turn off the fill in here if you like, or it's just a matter of unchecking it as far as the display if you don't want to see it. But this allows us to go ahead and pick it when we do the assign superelevation to corridor. It's a simple process. You click the button that asks you for the superelevation section. So that would be the only one we have right now is that one. And reset, and then locate the corridor. So I pick the corridor boundary. And it will bring up this dialog, which is how it tries to assign lanes to points. Okay? So all you've got to do is review this and make sure that it's set up the way you want it to pivot, or the way you want it to work. So I have to remember how I laid out my lanes, and then where my superelevation and pivot points are. So I'm going to start with the right lane, the right 2, which is the 28 foot. The superelevation point is going to be the outside edge of pavement, which is the right DOP out, and it needs to pivot about the right PGL in. Okay, so that one's set up. The inside, the right one, is the 11 feet from 0 to 11. And so that is going to be controlled. The point that needs to rotate or move is the PGL in point, and it needs to rotate about the pivot. And then the same thing with the left. So everything appears to be laid out correctly. And it also has my corridor limits out here. And so then I just choose OK. And what it's going to do is go recalculate the corridor and apply the superelevation lanes and transitions to the actual corridor shapes. So you can see it swirling down here. It's just reprocessing. It's applying the controls to it. It may not update the cross-section right away. Sometimes it stops swirling and then it'll come back and swirl again. But if you just keep an eye out for the little home button down here in the microstation dialog, this one right here, that's when you know it's finally finished. Okay? So then I can just click out of this command, and you see that, in fact, I am now super elevated at that same station. And if I look, I'm in the middle of my curve here, and I'm rotating about the center point, because that's the method for which I set the super elevation up. So that is essentially the method for doing the centerline pivot. Now let's talk about the reports that you can get out of here, and if you want to do any editing, I can talk about the super elevation diagram. We already kind of showed that, but if you want to see a report of this super elevation or print it out, you'll have to go back to the actual design file that the super elevation exists. And I can do that just by right-clicking and doing activate or exchange. I'll go ahead and activate. And now I'm in this file. Then I can click on the super elevation section, and I can go to this little paperclip icon, which is the super elevation report. And I can get the reporting data for the stations and the percentage of slopes for it. And then you can just do a file save as. But one thing to note here is that you can also go to what's called a CSV file. These are style sheets that basically reprocess all the super elevation data into a format that you want to view. So if you like any of these, you can print them out. If you need to provide this, or let's say you need to revise some of these stations, or provide it as an input file, instead of having the software calculate it, maybe you've got some specific transitions, or you have someone that calculates the super elevation that comes up with all the other transition stations and values, all you'd have to do is save this out to, or first of all, go to this CSV file format. Notice that it's lane, and then the super elevation section, in this case R1, region 1, actually that would be the region of the chain, and then it gives you the station, and then whatever the value is at that particular station of the crossroad. And then there's some other information, whether it's a normal crown, crown out. Some of these are optional. You don't necessarily need to have them. They're more for descriptions in the reports than anything. But it's just a matter of doing File, Save As, and then you can go out and just click on this text file. The only way you have is actually a text file. And so you can basically save it as, so it already exists. I've already got it out there. The reason I show you that is because if you wanted to, instead of calculate super elevation using the e-tables, once you have a super elevation set, what I could also do is come out here and go to my F11, actually go to my editor and select this. I don't know if the editor will open up and then activate, so I may have to just change. Actually, it should open up right here. Okay. So here is all the basically the transition control lines for here, and it's basically all these lines. If I didn't like these, or if they needed to be modified, I could come in and edit these either here. I could also edit them graphically, or I could have edited those in the text file and done a import using instead of the actual calculate super, if you hold down this calculate super button here, it will give you the option to import super elevation. And then it lets you go out and pick a CSV file, or in this case it's going to be all files, and I know that in my project roadway file folder, I have a super elevation text. Actually, I think it's being saved in temp. It's just where the default location was. I didn't change it. So there's that super elevation text file that was just created at 941. If I choose to open that and then locate the super elevation section, which would be this line right here, and again, it seems like it needs to be in the active file. But at any rate, like I said, if you wanted to import from a file, you can select that file, and now it's going to reprocess the calculation here, and it's going to basically overwrite the entries that were already in there. But because they were the same, I did a save as. The point is, I'm just showing you how you can import from a CSV file just as easily. Okay, and then you can go to the editor once it finishes here. Okay, let's go back to this editor. Okay, it lets me pick it and use these commands, but I can't just use the select tool. What you're going to see is I probably have another set of entries here, which no. Okay, so it basically overwrote the ones that I had there. I wasn't sure if it would add another set of entries or if it would no, actually it did. They're just within each other. So you see there's actually identical entries here. So I should have probably wiped clean everything and then done the import. And I can't remember if this lets me delete everything at one time, or if it just, there was an issue at one time with it just deleting one row at a time, even though it would let you highlight those. So now we'll see what happens here with the editor. Just so you know, some of the other things about this super elevation editor that we've noticed in SS3, and that is that in SS2 you used to have the ability to right click on points in the super elevation diagram and add constraints and add like do actual edit moves and that type of thing. Notice how it's not clear. So now I can go ahead and do that import again, and I'll just have one set of entries. In SS3 so far, they don't have any graphical edits to the superelevation diagram. You can go into the actual table and set up constraints. It's really difficult to try to figure out at first. I did figure it out one day, and it's a new day, so I'd have to go in and try to figure it out again. It's just as easy, I think, to edit that CSV file and get everything the way that you want it, and then delete the entries and then re-import it, and then you'll have it exactly according to the stations that you've verified against a spreadsheet of superelevation calculations of some sort like that. Okay, so that again shows you a way to essentially go in and now you'll see I'll just have one set of entries here. Okay. Let's check the time, 9:46. The last but not least on my list of things to talk about, if we just do a little summary again. So we talked about creating the design file and putting the superelevation shapes in the XSRD part of that file. And then how easy it was to create supersections. The fact that you can create sections by station limits is powerful. And then it's real easy to define the lanes and calculate the superelevation either from an input file or from initially the e-tables. And then editing those shapes, you can either do it graphically or you could go in the Project Explorer and change stations, change lengths, change widths, change slopes. We talked a little bit about the superelevation controls within the templates, specifically flags and rollover situation, but also the constraining to rotate the way you want. Assigning the superelevations sections to the corridors, just a simple button. Viewing it in the cross-section viewer, superelevation reports, and diagram editing. The last but not least is understanding what happens in the background. Okay, and that is superelevation point controls. So if you're used to doing it in SS2, then it isn't going to be any different in SS3. So what I've got to first do then is to deactivate this default model. So I'm going to deactivate the XSHRD file. And now I'm back in my design file. And if I go to my corridor objects and click on this corridor, it'll bring up the corridor objects folder. And disregard this red template, it just probably needs to be synchronized. But if I look at the point controls section of this, you'll see that now I have 4 superelevation controls. So that's just like in SS2, where when you applied the superelevation wizard, what you were really doing was creating a vertical control. If you look at how this reads for the very first one, so this is the left edge of pavement out. And it's being controlled. Remember, we can do it by horizontal, vertical, or both. So it's got a vertical control on it. And now it's going to use this control called superelevation. And there's all the different types of vertical control that you can apply. So this was done behind the scenes. And then it picked the one called Web Today Left 2. So in the superelevation diagram, each one of those lines have a name. And so the one that's controlling the left edge of pavement out is this Web Today 1 Left 2 line. And the one it's referenced, or the pivot point, is the point that it's controlled by. So that would be the inside point. If you were to look at the PGL point, it's going to basically say that this is the point name. It's a superelevation control. It's using the left 1 control line, and it rotates about the pivot point. And then the same thing on the outside. So these are being controlled. These are basically being created behind the scenes. Once you understand how all this works, then applying superelevation on projects gets really, really simple. Because now I have a specific line, and let's say I had another 4-foot lane out here that I forgot to put superelevation control on. All I've got to do is assign the same control line that controls this point to this outside point, and now I'm controlling that outside point in the same way as this, which is what you typically want to do anyway, unless it's a different slope. this is the key to the whole thing, is that whenever you lay out your super and you do the assign or the associate super elevation to corridor, what it's really doing behind the scenes is it's applying these point controls to points on your template. Notice how they show up in little magenta boxes. Okay. Now, the only caveat here that I have for doing rotation about the inside edge, and the reason we have to do that, if you look at this one diagram here, in the standard 511, you'll see that what I did here is I kind of cheated. I just basically set up my roadway so that it would essentially just rotate up one side. If I had used a design speed of, say, 45, it would have to have gone up to probably 28 or 27, 28, and in which case it would have had to rotate everything from the inside. Okay? If you know you have that situation once you calculate it, then what you've got to do is you've got to set your lanes up from the inside out. But because I was going to rotate about my pivot point, I didn't have to necessarily worry about it. I set my lanes up from the pivot point out, left and right. Okay? So all you would do is you would come into your, unfortunately this is left is our project that should rotate about the left, the right side, but let's just assume it's that way in this diagram. So I would have set up my lane 1 as left 28 feet, lane 2 would be left 2 at 11 feet, lane 3 would be at plus 2%, and then lane 3 would be again left, and it would be 39. It would start at 39 or whatever that total width was for 11 feet, but it would be a negative 2, and then so on and so forth. So you can set your lanes up from this inside edge. You just have to make sure that you set your section up so that it's controlled about the outside edge, and then you set lane 1, lane 2, well actually lane 1, lane 2, lane 3, lane 4, and then when you go to associate it to the corridor, you'll just have to make sure that your template is constrained to the right side so that this is actually the pivot, and this rotates about this pivot, this rotates about this pivot, this rotates about this pivot, and from the right side out accordingly. And if you do that, then when you go to actually apply the super with the lanes configured the way they will, it will rotate about the inside of your curve. And it will rotate so that it holds this as your profile grade line, and essentially actually moves that pivot line up. Okay. And actually, this is not the actual profile grade line. It's actually this. It's actually sloped down from the profile grade line, if you will. It's easier to see in your template. So this is where your profile grade line is supposed to be, and so it's supposed to hold this edge, which is really the width times the slope below that, which is 5600ths. And so then it holds this, and everything would rotate according to this point. This would rotate up. Even your center line has to rotate up, just like it shows in the diagram, where the actual center point actually has to rotate up through the super till you get to the max, and then it all comes down, and then it breaks again. So that's how you would apply that. So that covers what I had planned to show. I went a little bit more into details as far as how to handle inside curves. I'm going to go ahead and see if there's any questions. I'll go ahead and address those questions next. Here is my contact information. Anything regarding the super elevation that you need on your projects, feel free to give me a call. I've helped a lot of people out in the past getting the super elevation set up correctly. So let me just take a look at any questions there might be out there. Take the remaining time to answer these questions as best I can. All right, so there's only a couple questions. What about the outside type F curb and gutter slope? Alrighty. Yep, so that is kind of what Brad said, and that is it's a vector offset on the outside of the curve as well. I specifically addressed the inside, but you do have the same situation on the outside. Do we see microstation, simple geometry, graphic warning, rule violations, and where superelevations and modifications fall outside of FDOT standards? That question, I'm trying to think. Not particularly, you don't. I think when you lay out the original superelevation, it will use our standards, but if you go in and modify those, there aren't any flags really that come to mind in SS3. In SS2, it would actually color code in the superelevation diagram when you were overriding a value. It would let you unconstrain points and override values. But in SS3, that isn't built in yet. So you just got to be careful when you lay out your super. And of course, you have the ability to print out the reports and give them to your superelevation gurus to make sure they're checked out right. And if he doesn't like them, he can modify the numbers. And like I said, you can create that the CSV file and go change the numbers to meet what he certifies or he's going to sign and seal, and then apply it back to your corridor, and then do your checks in the cross sections to make sure you've got it set up right. That's typically the workflow that designers, I guess, would go through. And maybe they will have some of those flags in the future so that at least you're alerted to it. It would be something we could ask Bentley to go ahead and add in there. I know they talked about adding some additional, some more functionality to the superelevation editing diagram, but I haven't heard much lately. They're also talking about adding in criteria as well as in the SS2 quarter modeling. You had the ability to rotate. It was just a checkbox as far as which point on your template to rotate. You didn't have to go through this lane configuration from the one side out on inside curves. You could just hit a checkbox and it would automatically calculate it based on the rotating from an outside edge or an inside edge or a middle pivot. And hopefully they'll be adding that functionality back in, because it was in the criteria method. It was also in the superelevation quarter modeling wizard. We had that ability there too, so hopefully that'll come. Well, if there's any other questions, feel free to give me a call. Thank you for attending this webinar, and that should be posted as usual within the next day or two. And I hope you all have a great day.